So here in this problem, we are to determine the equation of a circle whose radius is 5 units and it externally touches another circle whose equation is given to us. And it touches this new circle at the point 5, 5. So let's start with a problem. So let's first try to understand the problem graphically. Well, let's say we have a circle here and the circle's radius is known to us. So if we assume that this center is C, then the radius is known to us. Let's call the radius as 5 units, and this circle is touching externally another circle. So let's say this circle, we don't know for sure yet what's the radius, which we can find out. We'll do that in a moment. So let's say we have another circle. It's touching externally at this particular point A. This coordinate point is given to us. It's 5, 5. So here we have this equation of the circle is given to us. Using this equation, we can find out the coordinate of the center. So let's call it C prime, as well as the radius of the circle. So we can find it out as this. Find it out easily. And using all this information, we need to find out the equation of the circle having a center C. So let's begin. So we will start with the yellow circle. So here its equation is given. It's x squared plus y squared minus 2x minus 4y minus 20. So we'll transpose 20 to the right hand side. Now our task will be to first write all the terms containing x. So we have x squared minus 2x, and we'll combine all the terms containing y. We have y squared minus 4y equals to 20. Now we'll convert this two terms, x squared minus 2x, into a perfect square, and this y squared minus 4y into another perfect square. Let's do that. So we have x squared minus, now we will express 2x as a multiple of 2. So we have 2 times x times 1. So this number 1 is going to tell us that we add the square of that number, and that's an extra term. So we'll again have to subtract 1 squared from it. Similarly, we will rewrite y squared minus 4y as y squared minus 2 times y times 2. And this particular number 2 is going to tell us that we need to add 2 squared to it and also subtract 2 squared to it, because 2 squared is an extra term that we have added. This will be equals to 20. Now we can see here that x squared minus 2x plus 1 whole squared, this is nothing but the expansion of x minus 1 whole squared. Then we have y squared minus 2 times y times 2 plus 2 squared, that is the expansion of y minus 2 whole squared. So this will be equals to, so we'll transpose 1 square to the right hand side. We'll also transpose 2 squared, so that's 4 to the right hand side, and we have 20. So 20 plus 4 plus 1, so that's going to be equals to 25. So now we have obtained the equation of the circle in standard form, and this is going to help us obtain the coordinate of the center as well as the radius of the circle. For that, we'll use the standard form of a circle. So we know that the standard form of a circle is given by the formula x minus h whole squared plus y minus k whole squared equals to r squared. So here the center is represented by the coordinate h comma k, and we have the radius. So the radius is r, which we have found out to be 5. So that means we can say here that the value of h is going to be equals to 1 and value of k is equals to 2. Or in other words, we can say that the coordinate of the center is 1, 2. So this is the coordinate of the circle with center C prime. We have obtained this value. So we have our circle whose equation we need to determine. So here we have the circle C. We're going to consider that let the coordinate of this circle be alpha, beta. So we'll suppose this. And the circle is touching the yellow circle at point A. So let's say its coordinate, which is given to us, it's 5, 5. And we just now found out the center of this yellow circle, which is C prime. So that came out to be 1, 2. Fine. Now what we'll do? We'll do construction here. We're going to join CA as well as AC prime. Now, the radius of the circle, so this is given to us, this is 5, and we obtain that the radius of the yellow circle, that also came out to be equals to 5. So that means the point A is going to lie between C and C prime. That means we can find out alpha plus 1 divided by 2. This will be exactly equals to the midpoint, the x coordinate of the midpoint, which is equals to 5. Then we can add the y coordinate, which is beta, plus 2, and divided by 2, and that's going to be equals to the y coordinate of the midpoint, which is equals to 5. And this is going to help us solve for the value of alpha and beta. So we have alpha plus 1 equals to 10. So alpha is going to be equals to 9. Then beta plus 2, that will be equals to 10. So we have beta equals to 10 minus 2, so that's going to be 8. So we have found out the coordinate of the center C. So alpha and beta, so this came out to be equivalent to 9, 8. So we have the center, and we know that this is equivalent to h, k. So that means the value of h is going to be equals to 9, and the value of k is going to be equals to 8. And the radius, that's already known, that's 5 units. So therefore, the equation of the circle is going to be x minus 9 whole squared plus y minus 8 whole squared. That's equals to 5 squared. So this is the standard equation of the circle with center C, and it's going to touch another circle at point A with coordinate 5, 5, and the center of the yellow circle is 1,